Okay, so today we're going to take a peek at two different equations for lines and try to determine whether or not the two lines are parallel or perpendicular or if they are neither. So we need to make sure that we understand what are parallel lines, what are perpendicular lines, what are neither lines, right? So parallel lines are those lines that have the same slopes. So parallel lines have same slopes. And then perpendicular lines, remember, have those opposite and flip slopes, fancy words, right? Opposite and flipped slopes. So like if your slope is 1/3, your parallel line would also be 1/3. If you had a 2/3 and we wanted the perpendicular slope, that perpendicular slope would be a negative, and then we flip it, -3/2. If by chance it doesn't fit either of these two things, so if they are not the exact same slopes, and they need to be exact same, and if they're not the opposite and flip slope, then it means it's that last neither version. So we need to be careful and be reminded of, like, when do we know the slopes, right? We know slopes when we have a slope-intercept equation. We know slope when we have a point-slope equation, but we don't know slope when we have a standard form equation. So when we look at our equations, right, we know the slope if we have a slope-intercept equation. It's the number in front of the x. We know slope if we have, I'm just going to highlight that really quick, right? There's our slope right there. We know slope if we have a point-slope equation. So if we have a point-slope equation, we know the slope is here also. But standard form equations give us no information. So if we have standard form equations, we have to turn them into slope-intercept usually. Is the easiest to figure out what that slope value is. Okay, so what we're going to do is we're going to start comparing these slopes. We're going to take an equation like these two. So we have two equations right here. And ultimately what I'm going to be asking you to do is come up with the slope of the first line, and then come up with the slope of the second line, and then we're going to compare the two answers. So I have my two equations, right? So I have these two equations. The first equation is obviously in slope-intercept form, so it's a little bit easier to name that slope, right? So I know that the slope of my first line is this 4. So I can go ahead and label that slope. I'm just going to write it out. So line 1's slope is 4. Right now, I don't know what the slope of this line is because it's in standard form. So because we don't like standard form equations, we always take this equation and get the y alone to turn it into intercept form. So we always get rid of the x. So if I take this new equation and I take away that 4x to both sides, so if I minus my 4x here and I minus my 4x on the other side, oops, 4x, and if I minus my 4x on this side, right, on my left-hand side, I'd have my y. On the right-hand side, I have my 3 and my minus 4x. So I know then what my slope is. I know that that slope is that number in front of the x, which is a -4 for this one. So I'm going to list that out. My slope for my second one is -4. And then I'm going to compare the two slopes. So because 4 and -4 are not the same, they're also not opposites and flips, because remember, it has to be both. They are opposites, one's positive, one's negative, but they didn't flip that fraction, which means that these two equations are neither. They are neither parallel, they are neither perpendicular, so they are neither of them. If we were to graph them, they would just be some sort of intersecting lines, right? Let's do another one. Okay, so this equation set, right, we are given two equations, and both of the equations this time are in standard form. So I need to do some work to both of these two equations. I'm going to scoot some of this stuff over so it's easier for me to have some space. All right, so I've got two equations, right? Both of these equations are in standard form, so I have to do work on both of them. So I'm going to take the first equation and then do the work for the first one, right? Standard form equations are the most useless form of equations. So we're going to do a little bit of math. We're going to get our x out of here. Get our x out of here. So I drop down my 5y. On my right side, I have a 10 and a minus 3x. And then I got to divide by the 5, all the 3 parts, right? We've done this a lot already. When I divide by 5, I'd have y equals 10 divided by 5 is 2. Negative 3 over 5 stays because I can't even simplify it. Negative 3/5 with an x on it. So I know now that that slope is that negative 3/5. Right, so I'm going to write that out so I see it better. So I know the slope of my first line is negative 3/5. And now I'm going to figure out my second slope, right? Because my slope is in standard form, I don't know it yet, or my equation is in standard form. So I'm going to minus my 5x to both sides. Always get rid of your x first. So I'm going to subtract my 5x, subtract my 5x to both sides, which is going to leave me with this negative 3y on this side, and my negative 6, and my minus 5x on the right side. And then I can divide everything by that negative 3. I'm going to divide by negative 3 all 3 times, right? When I divide by a negative 3, I'd have y equals 2 negatives, make that a positive. 6 divided by 3 is 2. 2 negatives here, make this a positive, so positive 5/3 with the x on it, right, for that slope. So 5/3. Let me make sure that you can read that. Then, right, I can compare those two slopes. When I compare the two slopes, my first slope is a negative 3/5. My second slope is a positive 5/3, right? If one's negative and one's positive and those numbers flipped, then that means that these two lines are perpendicular. You could choose to write out the whole word, right? Or if you want to use the symbol for perpendicular, you can do that as well. So what I would like you to do is I want you to try this. We're going to go to number 4 first. So I want you to try number 4 first. You'll see why in a minute. So try number 4, pause the video, you try it, see if you can compare those two slopes, and then we'll check your answers. Okay, so check your answers with mine and make sure you get the same answer as me. So I'm going to take these two equations and find the slopes of them, right? When your equation is in standard form, it's harder to name the slope, right? So I'm going to first subtract my 2x from both sides. So I minus my 2x and I minus my 2x. I'm going to show my work, kind of squish it over here. So I'd have my 5y on this side. And then on the right side, I have my 15 and my minus 2x, right? I'll do this equation in a minute. And then I would divide everything by that 5. So I'm going to divide by 5 all the 3 parts. If I divide by 5, divide by 5, divide by 5, I'd have y equals 15 divided by 5 is 3. And a negative 2/5 with the x, which tells me my slope is that negative 2/5. And then when I do my second equation, right, I would minus my 3x to both sides, minus my 3x to both sides. Standard form equations are kind of useless, right? We have to turn standard forms always into slope-intercept to be able to like make them user-friendly. Divide everything by the 5, and I get y equals 3 minus 3/5 x. Right, so then I'd have my slope is that negative 3/5 again over here. Negative 3/5 and a negative 2/5 are not the same. They're also not opposite in flips, which means these two are neither, right? They're not parallel and they're not perpendicular. Okay, so I want you to try one more on your own, and then we should be good to go. But this is what you're doing today, comparing equations to see are the two equations, if we were to graph them, would you get a parallel set, a perpendicular set, or neither? So here's number 3. I want you to try it. So I want you to do the math, pause the video, write those two equations down, check to see if their slopes are parallel, or if they were perpendicular, or if they would be neither. Okay, so let's check our two equations. I'm going to separate these guys a little bit, right? So I'm going to take my first equation, right? Standard form, get the x to the other side first, which would give me my 7y on this left-hand side, and then that negative 35 and the negative 2x on the right side. Divide by 7, divide by 7, and divide by 7. 7s are gone. Y equals negative 35 divided by 7 is negative 5. Negative 2 over 7, can't do anything with it, so negative 2 over 7 with that x on it, right? So I know my first slope is a negative 2/7. And now I can do my second equation, right? You do have to show all of this work, right? Because we don't know what the slopes are when they're written in standard form. So we got to do the math to turn them into standard form. minus my x to both sides, which leaves me with a 14y and a negative 42 and a minus 4x on the right. Divide by the 14, all the parts, divide by the 14, right? I'm going to do this division for you. Negative 42 divided by 14 is a negative 3. Negative 4 over 14, right? That's going to be a negative. And then 4 and 14, I can divide both by 2, which would give me a 2 and a 7, right? So 2 7. So this slope, if we can't, right, divide, then we try to simplify if we can. If both of my slopes are that negative 2 7ths, then these two would be parallel lines, right? You could either write out the word parallel or you can put in that symbol for parallel. So just make sure this part makes sense, right? In order to tell if lines are parallel or perpendicular neither, all we really need to do is compare those slopes, right? If they're the exact same slopes, then they are parallel. If they're opposite and flips, remember they have to do both things, a negative and a positive, and the fraction needs to flip. Don't get confused, right? When you're walking through them, if you have these written down, you'll have the examples that you need, right? We don't know the slope when we have an equation in standard form, but we do know the slope when it's written in slope intercept or in point slope. Okay. If you do happen to finish early, right, you can always go into IXL. 8th grade math would be the good thing, or the Algebra 1 pieces. There's lots of things you can practice in that linear equations. Typically in 8th grade would be the best place to start.